Hello, boys and girls, ladies and gentlemen, So, I've got some cabling. So the first part of this video here is I want to show you the difference between the shielded cables and the non-shielded cables. Plasma ball. Everybody loves plasma balls. Now, over here on the right-hand side, you will see an oscilloscope. Neat, eh? So the idea of this guy here is you can see electrical noise interference. And now the way that this plasma globe works is that there's a flyback transformer in it that is driven by a 555 timing circuit to create a PWM pulse, which simulates AC ultimately, and then is then stepped up using the flyback transformer inside. So, because transformers don't typically work with DC, you need the alternating current. You need levy forces, or levy currents, and currents in motion. It's kind of neat. So anyway, you can see on the oscilloscope here that when I touch this thing, that you can see the waveform go nut. These nuts! In fact, as soon as I bring my hand near this and I pick up the little antenna is basically what it's acting like, right? I've got it set for 0.1 volts right now. You can see that it goes ape shit, right? Now, what you're gonna do here is I'm just gonna move this off to the side, but I'm gonna leave it running because I wanna use it to generate noise. Yes, all right, so now, first of all, let's just take a look at a regular piece of Cat6 here, okay? I'm just gonna, wow, that just goes nuts, right? And I mean, like, even if I go on the end like this, let's see here, I think it's that one. So you'll see I'm getting a very, very low noise when I do it that way, though. But essentially, this is acting as a giant antenna because there's absolutely no shielding in it. And this is just a regular piece of Cat6 non-shielded, okay? So now, you saw how dead that one was. So now, I'm going to take this, but I'm not going to connect the ground to it. Now watch the oscilloscope here. And I'm going to, it just goes off the chart, right? Let me dial it back a little bit. I'm picking up like volts. That's crazy. There we go. So look at that nice, squishy sine wave, right? Can I zoom out on that? There we go. It's already set for 100 megahertz. It's pretty wide. But yeah, basically this is acting as an antenna. Now the cool thing is that if I take this guy here and I clip it onto the ground here, which will then ground this entire cable, we get nothing, right? Now I'm gonna go back over to my voltage and let's make it stupidly sensitive again. Here we go. Nothing, see that? I'm on the center pin here. These pins aren't grounded, by the way. So what I did was I actually put some electrical tape over the pins so that they do not become shorted. And then I wrapped foil around here so that it's in contact with the shielding on here, which will then in turn put it in contact with the shielding inside of the cable. So as you can see here, we're not getting any noise, and I can actually, let's go down to 50 millivolts and see if we can get anything. It's very, 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 very clean. And that's how this Cat7, I believe this is the Cat7 cable, this is the Cat8. This is how the Cat8 can run at such high speeds, is because it's extremely shielded. Everything inside of it's shielded. We're gonna see that in a minute. Now I'm gonna put this one aside. Let's go over to the Cat6 here, regular Cat6. Look at that, off the chart. And if I connect this here like so, it doesn't matter, it goes off the chart because there's no shielding in it, okay? So Cat6, they say for short distances can do 10 gig, but for, you can use it for, well, I already did a little video on discussing that. Cat6, about the same as Cat5 realistically. The big differences between Cat6 and Cat5 are the amount of twists per inch. Where Cat6 is really handy is if you've got a long cable run and you're seeing signal degradation and you're dropping down to 100 meg. Cat6 will help a little bit, and not all Cat6s are built equally. And when I say Cat6, I'm referring to the Cat6A. Some of them use heavier cable gauges, some of them use lighter cable gauges. Most of them have the separator inside. There's variances on these guys, which is why I'm saying ultimately Cat5e and Cat6 don't make too much of a difference for our application when it comes to towers. So now let's take a look at the Cat7 here. Cat7 is also shielded, and this is good for, I believe, up to 10 gigs for sure. Here we go. And you can see here that it's off the chart with the noise. But now let me connect the ground here, and again, this ground is only connected to the grounding on the chassis here, like so. Now watch. See, so still getting a little bit of noise, but not nearly as much, right? So the Cat8 definitely has better shielding to it. There's a lot of noise right there coming off of these guys. And then when I connect the ground to the end here, you can see that, no, there's really not that much noise. Let me go 10x. Let me go 10x. See? Dead. Absolutely dead. Otherwise, look at all that noise. And that's just from the plasma globe sitting off to my left. So isn't that interesting how the cable actually keeps the noise out? And this cable here will say what what bandwidth it'll do. So this will do 40 gig base T, Cat8, 2,000 megahertz is what it's capable of handling. I think Cat6 is only good for 350 megahertz. And that's the channel width of the comms channel between the transceivers. Now, let's do the next thing. Let's move this oscilloscope aside. And by the way, if you're wondering what's happening here, this ground is actually going to Earth, and then the ground on my probe is also connected here. There you go. That's me using an oscilloscope. Let's move on to the next step. Let's take a look at what the inside of first of all, let's start with this Amazon Basics Cat6. I want to see if it's the same as my StarTech Cat6, because they definitely don't feel the same. In fact, the diameter of this is about half the diameter of this one, if you can see that. So zoom it in a little bit. See that, right? Okay, so now let me get a set of cutters. Sacrificial cables. Okay, so first of all, let's look at this Amazon Basics one. Here we go. I'm going to cut the end off, and let's see what we got inside. All right, so this one has the plastic separator. Oops, there we go. That's Cat6. That's the plastic separator inside. Now look at how light gauge these wires are. See what I mean? These are this is lighter gauge than standard Cat5e. But look at all the twists per inch. In fact, let me grab a caliper. For you guys following at home, you can go and look up how many twists per inch they're supposed to be, but let's go to 1 inch. 1 inch on the dot. Boopity boop, close enough. Okay, so now let's see here. So if we look at the green, that's one of the datas. Now you'll notice that the green and orange here have got about the same number of twists in it. The blue does as well, but then the brown does not have nearly as many because the brown is almost a spare. Most of the data is done over all of the pairs, right? And of course PoE and stuff too, but let's check this out. So how many twists per inch do we have? We've got, let's see here, 1, 2, 3, 4. 4 twists per inch there, if I'm counting that correctly. So we're starting there. So 1, 2, 3, 4. 4 twists per inch on this Cat6, and a very, very fine Cat6 this is as well. And this is stranded because stranded cabling is typically used for high mobility applications where this stuff's moving around a lot. Let's take a look at this Cat6 cable now, because these are not all built the same. Wow, look at the difference in size of these cables. Okay, so if we look at that and see these, look at the thickness differences, and let's see if this one has the same amount of twists per inch. 1, 2, 3, 4. 4 twists per inch on this Cat6 as well. And this one as well, same thing with the brown. The brown has less twists per inch. Got 1, 2, 3 twists per inch on the brown, okay? So neither one of these are shielded. So let's put the Cat6 aside, and let's get into the Cat7. So let's cut off the Cat7 head here. Oh, that felt good. How many of you didn't want to see that? That cable was 20 bucks. Okay, let's see here. We're gonna strip off the jacket. Oh, look at the inside of that. So here's the first thing, is that we've got some lovely, lovely, lovely. Okay, so we've got our braided cabling here. So this is the braided jacket, okay? And we see this in cable like the Ubiquity Tough cable, which is the cable that I specifically use for doing towers because it's cost effective and it's built like this, okay? So we just took off the first layer, which is all this braid. So now we've got a foil. This is like one of those, you know, it's an inception of cabling. I have a feeling this is very light gauge. Okay, let's see here. See if I can't get, I should turn off the plasma globe now so I don't interfere with my mics or anything. Now look at that. Look at how much there is. And then there's shielding on each pair. Now this is far more rigid cabling here. So let's take apart the green pair now and see how many twists per inch there are in it. Would you look at that? There's less twists per inch. 3, actually 2.5. It's almost like Cat 5. Now why is that? The purpose of the twists in the wire is to inductively kill interference. So with all these little twists in the wire, the idea is that they basically are creating like almost like a transformer, so that any kind of external flux that comes across these guys or external electromagnetic fields will actually cancel each other out because these wires are wound around each other. Okay, so that's the purpose of that. Now, since the Cat7 has got all this foil wrapping on it, it doesn't need that at all. But there's still twists in it, of course. This is actually almost like a Cat3 twist that's in it. So that's crazy on that. Now let's take a look at the Cat8. I wonder if the Cat8 is very much different from the Cat7. I'm cutting a Cat8 patch cord. Ho ho ho. 40 gigabit. Here we go. So let me get some of this foil off. Wow, this is very different actually. So first of all, there's no braid in this cable. There's definitely foil. Here we go. Now, so we've got some foil here on these leads as well. Where's green? Here's green. Let me take a look at green now. just like the Cat7, this only has officially like, what, 2 twists? So way, way fewer twists. Let's see, check that out. So the Cat7 and the Cat8 have the same amount of twists. They're shielded the same, and in fact, this, I don't know if I can trust this cable here that came from Amazon, but this Cat7 cable actually has better shielding than this Cat8 cable, actually. So isn't that an interesting point? Okay. This is supposed to be Cat8. And then you look at the Cat6 cable here, right? So that's interesting. So this guy here, the Cat6, is a cheaper cable, and it's got a divider in them to keep the cables from touching each other, and to also have more twists in it per inch. I just want to take a look at the brown on this thing as well, because I want to see if the brown is neglected the same way as the other ones are. It's hard to tell. Yeah, the brown has the exact same amount of twists per inch in this. Now, there's also a drain wire on this one, too, but realistically, look at that. I mean, the Cat7 actually has the same... Honestly, to me, the Cat7 here feels like proper Cat8, and this Cat8 doesn't feel like Cat8 at all. So that's kind of interesting. But, yeah, there we go. We got to rip apart some expensive cables and see what they look like on the inside. So to reiterate, one more time, Cat6, no shielding. Has lots of twists per inch on these cables. Cat6 usually has heavier gauge cabling. This is a very, very light one because of the PC patch cord, right? The Cat7 here that I ordered has got the exterior braid, then an internal foil, and then each of the pairs themselves have foil wrapped around them, right? And then the Cat8 actually didn't even have the braid on the outside of it. So I would almost say, just looking at these 2 cables here, is that this Cat7 cable is actually better than this Cat8. Now, something else to note is that because these are shielded, they can actually handle a lot better. In fact, let me just grab a piece of outdoor cabling and I'll show you what I mean. All right, I don't have any tough cable carrier on hand, but I do have some regular indoor Cat5. So we're gonna take a look at that. Now, the tough cable carrier from Ubiquiti, there's also a Shireen, and there's another product as well out there that's the same, where basically it's got the braid here over top of the pairs, but it doesn't have the internal foil. So imagine a cable just like this, except having foil over the top of that, and then having the braid over top of the foil, and that's what the tough cable carrier is like, okay? So now let's take a look at the twist per inch on the green on this Cat5. And we've got 2.5 twists per inch with that one, okay? So now, if we compare this, I'll bet you the Cat7 and Cat8 have almost the same amount of twists per inch as Cat5. Interesting, no? So that's regular shitty Cat5 indoor, Cat5e. Now let's take a look at a piece of installer cable, which is UV shielded, shielded Cat5e. So this stuff we use for installs, okay? Look at this. What is inside of here? Let's see if I can strip it well with these things. Here we go, I got it started. It's impossible to cut this stuff properly. You know what I might have to do? Let me pull this pull cord. And that's what this little string's for, by the way. It's actually called a rip cord. It's for opening cables. There we go, that's better. So now if you look inside of here, you can see behind the UV shielded stabilized cable, we've got a foil. And if I peel this foil back, you're gonna have this plastic coating on the inside of here to keep them separated. Gotta keep them separated. Now let's take a look at the twist per inch on this compared to that piece of indoor Cat5e. Let's see here. Now this is the interesting thing about outdoor cabling, by the way. See, not all cables adhere to proper standards. So if you look here, there's more twists per inch on this piece of Cat5e tower cable, or sorry, installer cable, but twice as many. How many are we gonna have here? 1, 2, 3. So we've got 3 twists per inch on this Cat5e outdoor cable, and we've got about 2 on this regular indoor Cat5e cable. Isn't that interesting? So now, if we compare this to the Cat6, you will actually see it's almost as many twists per inch on this outdoor Cat5e as there are on this good quality indoor Cat6. Nearly identical. So this stuff here, this Cat5e outdoor, is actually, technically, you could qualify it as Cat6. The differences here, right? And that's probably why the tough cable carrier works so well. So there you go. It's got to take a look at some different cables tonight. Oh, and you know what? Just for good practice here, I should probably do a check on the noise rejection of this, because this is why if you've got an FM tower site and you're having issues with your tough cable carrier or your other double shielded cabling, that the Cat7, Cat8 cable will actually solve the issue is because it's all the extra shielding in it, right? So I'm actually going to take this, and I need the drain wire here. So I'm going to peel the drain wire back. I'm going to put a little bit of tape around the end of this so that I can, here's some, isolate it electrically like so. Now I can put a piece of foil over it with this drain wire here. Watch. And this will ensure that the whole thing's grounded properly, right? Cool. So there's that. Now let's do one more shielding test. Turn on the noisemaker. Here we go. So now if I take this cable like so, and I stick this on here, you're going to see it goes off the charts with noise, right? You can actually see the square wave generated by the PWM here. Now, if I clip on this ground here, like so, nice. There's like no noise there. That's pretty clean if you really think about it. Shielded cabling makes a big difference, doesn't it? But now if I took something more high-powered than this, here we go. Let's really get that on there good. Now, let me hold this on here like so, without touching it with my fingers. And yeah, I can't do it. I was hoping that I could actually get on here. You can see a tiny little bit of noise on there. Just a tiny bit of noise. So, yeah, there you go. Have anything that may not have been the most conclusive tests, but at least you got to see what all the different cables look like internally. Now, of course, I would strongly recommend you go on Google and look up Cat5 E, Cat6A, Cat7, and Cat8 cabling and read about it. Because there's nothing better than Google for finding sources of information. And if you check multiple sources, you can get good information. Yeah. You now got to see the differences between all the different cabling. Now, I did the relevant ones because we don't need to talk about Cat3 because Cat3 is typically only used for phone systems, and that is now obsolete, as we don't necessarily use Cat3 anywhere anymore because Cat5 is so much, it's just as easy to make, and it's, you know, we just don't have a real use for Cat3 anymore. So anyway, I hope you guys enjoyed. Don't forget to like and subscribe, tell your friends. If you want to help us out, join our Patreon. You'll get early access to videos and stuff. And in fact, Patreons have access to seeing live streamed recordings of me working on projects on the bench. So when Matt and I, the editor of the channel, are sitting down and working, he will actually be streaming this, and Patreons will have access to that. And yeah, so you kind of get a sneak peek of videos to come and uncut. So if I fuck up or do anything ridiculous, you're gonna see it. And we have a Facebook, we have an Instagram, we have a TikTok, Twitter. So yeah, join us, and I hope you guys enjoyed. Don't forget to leave comments about anything you want to correct me on, or if there's any video content that you want to see. Thanks a lot, guys.